Hello and welcome to another exam paper walkthrough. Today I'm looking at the GCSE Maths June 24 and this is a predicted paper that I've produced. It's a predicted paper for 1F. It's based on common questions as defined by Edexcel, your exam board, so it should be very useful. If you find this useful, please do subscribe if you like. So again, this paper has been created based on Pearson's skills, enhanced skills mapping document, and we're looking at common questions. They've been arranged in order of difficulty, and the paper is worth 93 marks. So we'll start with question 1 then. So we've got a scatter diagram, maximum temperature, number of hours of sunshine in 14 British towns on one day. 1 point is an outlier. Which one is the outlier? This is going to be our outlier. So I always go for the process of circle the one that you're going to describe. So I circle it first of all, and then write down the coordinates. So the coordinate of that is halfway between 9 and 11. And this is a real common mistake on the summer. Lots of people wrote 9.5. 9.5 is not the correct answer. Halfway between 9 and 11 is 10. And halfway between 18 and 20 is 19. So it's 10, 19. For the second part, for all the other parts, what type of correlation? We've got positive correlation. And then on the same day, in another British town, the maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine. So we need our line of best fit. So I'm going to try and insert a line of best fit. So I'm going to do this as a line. So I just want to create a line and then I'm going to move the line around. So I'll create a line and then I need to move it around. This is kind of what I would do with my ruler. I want the line to best match the data. So I move my ruler around before I draw my line. It doesn't need to go through any specific points, but that's going to be roughly my line of best fit. That will always pick you up 1 mark. An accurate line of best fit will always be 1 mark. Even if it doesn't ask for it. So especially if it's a 2-mark question where it says work out a value using a scatter graph, you get 1 mark for a line of best fit. And then we're looking at 16.4 as a temperature. The first time I did this paper, I got my axes the wrong way around and I did 16.4 on here. But it's 16.4 degrees. The graph is going up in 0.2s, so 16.4 is going to be just 2 above the 16. Go across, and realistically you should be using a ruler for this, just to save myself a bit of time. So I'm looking at roughly 12.8. I'm going to go slightly lower. I'm going to go 12.7. If I double check the mark scheme, what the mark scheme allowed for this, the mark scheme said anything between 12 and 13. So 12 and 13 was accepted in the summer. Anything between that was absolutely fine. The final point I absolutely hated in an exam. So I kind of argued this. It also appeared in the higher on the foundation, so it was a crossover question. And I thought the wording of it was really poor. A weatherman says the temperatures are higher on days where there is more sunshine. Does the scatter graph support what the weatherman is saying? And I argued back when it was done in 2017, no, it doesn't. I would have got the mark for it for my explanation, but what I argued was no. What the graph shows is the maximum temperature versus the number of hours of sunshine. So it doesn't strictly speaking say temperatures are higher. It shows that maximum temperatures are higher. But for example, it doesn't show, for example, that for an hour it was a very high temperature and then the temperature dropped. So I did try and argue that in the summer. I wouldn't recommend that though. Years in passing, I would say yes, it does support, but I always add, whenever I'm going through this question, clearing up the language. Yes, although the graph actually shows maximum temperatures are higher when there is more sunshine. So years in passing, I am happy with that as an answer. I am saying that I agree with him, but I am making a slight point that it's the maximum temperature. Okay, question 2. Table shows information about the daily rainfall in the town for 60 days. Draw a frequency polygon for this information. So frequency polygon, we're going to draw in a specific way. We need to plot our maximum temperature, we need to plot our frequencies at our midpoints. So our first group is from 0 to 5. So the middle of 0 to 5 is going to be 2.5. And we need to plot 2.58. So 2.58 would be that point there. For my next point, halfway between 5 and 10 is 7.5, and I plot 24 there. My next one, halfway between 10 and 15 is 12.5, and I plot 13 there. And then 15 to 20, midpoint would be 17.5, and I'm plotting 11. And then finally 20 to 25, midpoint, I'm going to plot 4. For a frequency polygon, we then join them up with a straight line. Polygon, many sides or many angles. Strictly speaking, we shouldn't join it up to 0, but I don't think you'd lose a mark if you did. Okay, question 3. Write these numbers in order of size, starting with the smallest. You've got 2 options here, and it's completely up to you. You need to either convert them all into ordinary numbers or convert them into standard form. And it really doesn't matter which one you do, it's which one you're most comfortable working in. Me personally, I'm more comfortable working in standard form. I find it less steps. But if you want to convert it into ordinary numbers, that's absolutely fine. This one is already in standard form. This one is not in complete standard form. We would need to multiply by, we would need to move the decimal point 1 more. So that would actually be 6.72 times 10 to the 1 more than that, so minus 3. This one isn't in standard form. We need to put the decimal there. So it would become 6.72 times 10 to the 6. And then this one, if I convert that to standard form, it would be 6.72 times 10 to the minus 4. And then when they're all in standard form, you can compare the indices, the 10 power. So this, because we've got the same digits, 6.72 for all of them, so we can just put them in order of their powers. So the smallest one then is going to be this one, which started out as 0.000672. My next smallest is this one, which started out at 67.2 times 10 to the minus 4, sorry. My next smallest one then from this list is this one, which was 6.72 times 10 to the 5. And then finally, that leaves me with my final one, which it started out at 672 times 10 to the 4. Okay, question 4. Here's the number line. Write down the inequality shown on the number line. So we're going to call the value. Actually, technically speaking, I didn't spot this the first time. Technically speaking, that letter should be P because we've got P here. So P, the smallest it could be is minus 3. The largest it could be would be 1. But then we need to decide on our inequality symbols. So P can be equal to minus 3. So P is greater than or equal to minus 3, but less than 1. That would be my full answer. Just looking to see whether X was acceptable. Yeah. So if you've got X instead of P, that would be absolutely fine. You wouldn't lose a mark for that. I only spotted it looking at the question again. Okay, question 5. This is our workout. So this is practice of our basic skill of multiplication. If I'm ever doing multiplication, I tend to go for the column multiplication. And if I'm multiplying decimal numbers, I would multiply out the digits. I would ignore the decimals and just multiply out the digits. If you use a grid for multiplication, that's absolutely fine. The grid is used for all over the place. So I have no issue with that as a method. 3 times 6 would give me 18, so carry the 1. 3 times by 4 would give me 12, plus the 1 would give me 13. 3 times by 5 would give me 15, plus the 1 would give me 16. Then I'm timesing by 40. To make that easier, I put a 0 in the units column, so I'm only timesing by 4. So 4 times 6 is 24. 4 times 4 is 16, plus the 2 becomes 18. And then 4 times 5 is 20, plus the 1 is 21. I then add these two numbers together. 8 plus 0 would be 8. 3 plus 4 would be 7. 6 plus 8 would be 14. Carry the 1. So the digits in my answer are going to be 2, 3, 4, 7, 8. Now, technically speaking, what I need to do is divide by 10 and then divide by 10 again, because this number is 10 smaller, this number is 10 smaller, so I need to divide by 10 and then divide by 10 again. I tend to do it this way though. I ignored 2 decimal digits in my question had 2 decimal digits, so my answer must have 2 decimal digits. And I do it like that. Although technically speaking, what I'm really doing is dividing by 10, then dividing by 10 again, but I count the decimal digits. Okay, so question 6 is a simplifying indices. When we've got them in brackets like this, we multiply the powers, so that's just going to become p to the 10. Real common misconception is that you add them. Just as a note, p to the 2 times by p to the 5 is when you would add them. Because of the bracket, you times them. Ooh, gosh, what's happened there? So, just a slight note. Right, next one, simplify. I don't overly labour these. 12 divided by 6 is going to be 2, so my number part would be 2. P to the 7 divided by P to the 3, you subtract the powers, so that would, x to the 7 divided by x to the 3 would be x to the 4. And then y to the 3 divided by y would be y to the 2. And I would just jump straight to that. Okay, question 7 then. This one was quite a tricky question, 5-mark question. If we break it down, so bonus of 2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 7 managers. The rest of the bonus is shared equally between 6 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, we will get 25% more money. Is the salesman correct? You must show how you got your answer. So I'm going to leave that last statement till right at the end. I'm going to start by trying to break it down to work out how much each salesman gets paid. So to do that, if I split between the group of 3 managers and the group of 7 salesmen, I'm splitting the money in the ratio of 40% or percentage to 60%. So if the money is 2,100, I would say that 10% is going to be equal to 4 times that. So, 10% would be equal to 210. So 40% would be 4 times that. So 4 times that would be 840. So the managers are going to get £840. For the other people, I could do 2,100 take away 850, or I could say, based on that logic, 20% is going to be 420. So 60% is going to be found by adding 20 and 40 together. So I'm just going to add these two together. So that's going to be 1,260. So my next step here is I want to work out how much each person or each salesman gets paid. So I need to do 7. I need to do 7 divided by 1,260. So 7's going to 12 fully once with 5 left over. 7's going to 56 8 times. So each person is going to get 180. So that's the bonus each person is going to receive. Now I'm going to go to this statement. If the bonus is shared equally between all 10 people, I will get 25% more money. If the bonus is shared equally between them all, that's sharing between 10 people. So if shared equally, each person would get £310. By the structure, each salesman gets £180. So I need to say, if the full amount is 180, half the amount, or 50%, would be equal to £90, and 25% would be equal to half of that, £45. So 25% more of this value would take me to £225. So that's the amount that he would get if he had an extra 25%. That's the amount he would get that if they were shared equally. So is he right? No. No, as £225 is greater than £210. Okay, question 8. Cycle race across America is, and we're given a value in length. One knows that his speed for previous races is 15.12 miles per hour. For the next race across America, he will cycle for 6 hours per day. Estimate how many days it will take him to complete the race. So I'm going to pick up my first processing mark for just showing my estimated values. The estimation questions, it's really interesting. If you go exact, you lose this mark. So I'm going to say that that is roughly 3,000. I will only ever go one significant figure unless it's easier in the long run for me to go more significant. 15.12 to one significant figure is approximately equal to 20. That would be closer to 20 than it is to 10. And then that's already to one significant figure. So I'm not going to change that. Estimate how many days it will take him to complete the race. So if he's cycling at 20 miles per hour for 8 hours, he will travel 8 times by 20. So he will travel 1,600 miles per day. So to work out the number of days, I need to do the distance divided by the amount that he's traveling a day, 1,600. Not the easiest of divisions to do. To be honest, I kind of did it like this. I halved both numbers a few times. Halved them again. And then I did that as my division. So 4's going to 75 fully. 4's go fully into 7 one time with 3 left over. 4's go into 35 fully. 32 8 times with 3 left over. So technically 18 3/4, so I'm going to say it takes him 19 days. And the mark scheme for this is always pretty much similar, although last year, according to Edexcel, when I went on an examiner marker feedback, you got 0 if you went exact. It's normally processing mark for estimating, a method mark for the multiplication element, and then an answer mark for your A mark. Process, answer, yeah. The second part to this question, and again, this one needs some thinking. So, Juan travels for the race. Juan trains for the race. The average speed he cycles at increases. It is now 16.27 miles per hour. How does this affect your answer to part A? Now, automatically you would think if he's cycling at a faster speed, it would mean that he does it in less time overall. But if you think about the estimation that I made, I estimated 15.12 as being approximately equal to 20. So if he's now cycling at 16.27, I would still say he's approximately 20. So it would not affect my answer. That's all right. So how would this affect your answer? It would not affect it. Affect, as I would still round 16.27 to 20. Now, if you, in your question, you rounded 15.12 to 15, you could still get the mark for rounding because you've rounded to two significant figures. And if you did that, it would affect your answer. Because I rounded to one significant figure, it doesn't affect my answer. So someone's just pointed out that I may well have said 1,600. I did mean 160. I do apologise for that. Okay, question 9. This is, so from above we're seeing a circle. From the side we're seeing a rectangle. From the from the front and from the side we're seeing a rectangle. So in the space below, draw the sketch of this solid. That's got to be a cylinder. From above we see a circle. From both the sides we see the same dimensional of a rectangle. So that's got to be a cylinder. Show the dimensions on your height, on your cylinder. So we've got a diameter of 4. And we've got a height of, this would be the height, so we've got a height of 5 centimeters. Okay, and question 10. Complete the Venn diagram for this information. So complete the Venn diagram for this information. So we've got the numbers 1 to 10, and we've got set A are odd numbers, set B are square numbers. So I'm going to try and do this in order. So 1 would go as an odd number. As a odd and a square number, so it should have gone in the intersection. 2 is neither. 3 is an odd number. 4 is a square number but not odd. 5 is an odd number. 6 is neither. 7 is odd. 8 is neither. 9 is both. 10 is neither. So that's my completed Venn diagram. So I tend to do it fairly easy for my marker, just as a tip, because your marker's looking for the numbers 2, 6, 9, 10 on their scheme. It has them written in that order, so I tend to kind of list them in the bottom corner. Yeah, so I've just put 9 in both, so I'm just going to take that out. That was my mistake. What I should have done there was 8. I think I've probably said 8 and started thinking in my head 9. Okay, and then the next one, a number is chosen at random from the universal set. Find the probability that the number is not in set B. So that little comma, is it a comma? That little, not a comma. Yeah, the little comma after, not a comma, what is it? Apostrophe. Yeah, the apostrophe after the B means not in set B. So we've only got 3 numbers in set B, so we've got 7 not in B. So 7 over 10. Question 11. ABCD is a parallelogram. EDC is a straight line. F is a point on AD, so that BFE is a straight line. Angle EFD is 35 and angle DCB is 75. Show that angle ABF is equal to 70. So the first thing I'm going to do is label the angle that I'm trying to find. ABF, A to B to F, so that's got to be that angle there. So that's the angle that I'm trying to find. The way I'm going to do it is I'm going to say that this angle here is going to be 35. And the reason being, and I can show it on the diagram if I wanted to. So I could put an arrow there, and then I could say vertically opposite. That would be fine. I'm going to put it in terms of a description though. I'm going to say that AFB, that's the angle A to F to B, is going to be equal to 35. And then I put my reason in a bracket as vertically opposite. And then technically it's vertically opposite EFD. So I'm also then going to say that this angle here is going to be equal to 75. And the reason being is these are opposite angles of a parallelogram. So I'm going to say BAF is equal to 75, and its opposite angle of a parallelogram are equal. So I've got two out of the three angles. So my final step is going to say that x is going to be equal to 180 minus the two known angles. So minus 35 plus 75. So that's going to be equal to 180 minus 110, which is going to be 70 degrees, which is what we were asked to show. I'm going to finish off with a description, the reason that there. Angles in a triangle equal 180. And that's that question. That's the 4 marks. 2 marks for the working, 2 marks for the reasons. Okay, on to question 12. Complete the table for the values. So I've done this with my Year 11 quite a few times. I've shown them the table function on their calculator, but I have said this could be on either paper. Here we go with it on a non-calc. So I've got to work out each of these values individually. I would always start with a positive value. So I'm going to do it kind of up here. So if x is equal to 2, y is going to be equal to 2 squared would be 4, minus 3 times 2, so minus 6, plus 1. That's going to be equal to minus 1. Right, so that kind of implies that we've got a line of reflection here. So ideally, well not ideally, I should expect that 3 would be equal to 1. But let's just see whether that works. If x is equal to 3, y would be equal to 3 squared, 9, minus 3 times 3, minus 9, plus 1. So that would be equal to 1. So that kind of makes sense. Now I'm going to do when x is equal to 4. So if x is equal to 4, y would be equal to 4 squared, 16, minus 3 times 4, minus 12, plus 1. So that would be equal to 5. And then the negative value is the one that I need to watch out for, but I am expecting it to be 5. If it's 5, it would match my other side. So when x is equal to minus 1, y would be equal to minus 1 squared is 1, minus 3 times minus 1 is plus 3, and then plus 1. So that is equal to 5, so we know that we've got that right. Then I'm going to join them up. Then I'm going to plot these points. So minus 1, 5, that point there, 0, 1, that point there, 1 minus 1, that point there, 2 minus 1, that point there, 3 minus 3, 1, that point there, and 4, 5, that point there. And then I finish off by joining them up with a curve. So a quadratic graph would have a curve. So you're going to have to do it freehand. To do it freehand, you keep your wrist on the inside of the curve. I'm just taking a cheat because I'm doing it digitally. Not many advantages writing digitally, but okay, so that's my graph. Again, you're going to have to do it freehand, so keep your wrist on the inside of the curve, kind of in that position there, and drawing it up with a smooth curve. Final part of this question, use your graph to find an estimate for the solution. Well, that's the graph, so it's asking us to make an estimate when y is equal to 0. Y is equal to 0 is that line there. So I just need to work out the x values when they cross. So by my graph, x is equal to 0.4. That's that point there. And when x is equal to about 2.6, that point there. Okay, question 13. Shape A can be transformed to shape B by a reflection in the x-axis followed by a translation of CD. Write down the value of C and the value of D. So I want to do a translation of A. Identify the one that we're going to move. Then identify the line that we're reflecting it in the x-axis. That's going to be this line here. So the reflection is going to take us down to here. And then I need to describe how I get from here to here. It's going to be a translation. If I kind of put it in, look point to point, we've gone 6 back, 2, 4, 6, and 1 down. So we're looking at -6, -1. Okay, and question 14. Again, very common question, or common starter question. I would do this in the same way every time. There are other ways you could do it that are much more complicated. I'm going to work out the two exterior angles and then add them together. So I'm going to call it, let's call it A and B for now. So the size of angle A is going to be 360 divided by the number of angles, or 1, 2, 3, 4, 5 divided by 5, which is going to give us 5 going to 35 fully, 7 times 1 remainder, so 72. And then I do the same for the other shape, so that's going to be 360 divided by 1, 2, 3, 4, 5, 6 divided by 6, so that's going to be 60. So the x is going to be those two angles added together, so 72 plus 60, which is going to give us 132. And question 15 then, show that. So for a show that, I always start with one side and make it equal the other side, or hopefully. So first thing, when multiplying fractions, I need to have them as improper, so I'm going to convert them both to improper fractions. The whole number times by the denominator plus the numerator gives us the new numerator. So 2 times by 3 is 6, plus 1 is 7, so that would be 7 over 3. Times by 3 times 4 is 12, plus 3 is 15 over 4. My preference for this is, you've got two options. You can multiply out the numbers, then simplify, or you can simplify, then multiply. I will always simplify before multiplying. So 3 goes into both into 3 and into 15. Goes 3 times into 3, 5 times into 15, which gives us 35 over 4. And then 4 goes fully into 35 8 times, with 3 left over, which is what we're asked to show. Okay, question 16. This was a really tricky question, so I'll break it down for you. When it's broken down, it's not that hard, but you struggle to actually view it in your head. Rectangular frame is made from 5 straight pieces of metal. So we've got visualizing it in your head was the biggest issue here. We've got 5 pieces of metal that make this frame. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. So in effect, we know these 4 lengths. We know these 4 lengths. I'll change colour for that just because. So we know the length of these 4 pieces. They're given to us in the question. This side would be 5, this side would be 12. So all the way around the outside, so all the perimeter of that shape is going to be 34 meters. But it's this diagonal that we don't know. It's the diagonal that we don't know. If I call that x for now, we can use basic Pythag to work out that length. So x squared is going to be equal to 12 squared plus 5 squared. Looks tricky, but 12 squared is 144. 5 squared is 25. So that's 139. And the square root of 139 is 13. So that missing length here is 13. Meaning that if I just add 13 meters to this, I would get 47 meters. It's all right. Sorry, 169. Yeah, completely right. 169. Thank you. So we've got 47 meters, and we're the weight is 1.5 per meter. So I want to times that by 1.5. I'm going to take a shortcut though. 1 times 47 is 47. 0.5 times 37 is going to be 23.5. Half of that, let's just double check. If I double that, I'd get 46 and another one 45. So if I add those two together, that will give me 47 times by 1.5. So what I've done is I've said one lot is 47, a half of it is 23.5. So the full amount would be 70.5. So it's 70.5 kilograms. And that's that full question done, broken down into the steps, 5 marks. When you've actually spotted that you're breaking it down into Pythag, add in the 5 lengths, timesing that by 1.5. It's actually, if you know the strategy and the structure, that's actually quite a fairly straightforward 5 marks. It is difficult to spot though. Okay, and then question 17. Here is a solid square-based pyramid, VABCD. Base of the pyramid is a square of size 6 by 6. That's not technically shown, so I'm going to put 6 there, just to help me out a little bit. The height of the pyramid is 4 centimeters. We have got that shown. The M is the midpoint of BC, and VM is equal to 5, so that's the slant height. Draw an accurate front elevation of the pyramid from the direction of the arrow. So most people are absolutely fine in spotting that this base has got to be 6. What people struggled with is the height. They struggled with picking whether the height was 5 or the height was 4. If you think about the actual height, from the side elevation, you don't see the slant height, you see the vertical height. So the height of the pyramid needed to be 5. And I think I've just gone wrong. That should have been a height of 4. So the vertical height was 4. So that would be my front elevation. That would be my front elevation. Work out the total surface area of the pyramid. So the total surface area of the pyramid, in effect, I'm going to draw a really simplistic net of a pyramid. In effect, that's going to be the surface area. We've got 6 by 6. And we know that the vertical height of it is 5. So I've got a square, 6 by 6. And I've got 4 triangles, so 4 times by a half of the base times the height. So that would be 36. And then 4 times a half is 2 times 30, so that would be 60. So the total height, the total surface area would be 36 plus 60, which is going to give us 96. And interesting. Final part. I've only got 3 marks on this question. Anybody tell me what the final mark is for? Adding the units. Yeah, I've not got a unit at the moment. So unit is centimeters squared. So an independent mark. You don't need to have done anything. You could have just added centimeters squared and left it blank. Other than that, you would pick up a mark. Okay then, so our next one that we're looking at is, sorry, I scrolled ahead with my group. We're moving on to question 18. So the mean length of 5 sticks is 4.2 centimeters. Now I'll measure the length of one of the sticks as 7 centimeters, work out the mean length of the other 4 sticks. So I will write this out before I even attempt it, and I'm not necessarily going to do this sum as a oneer. So I want to do 5 times by 4.2, subtract 7, and then divide by 4. So that's in effect what I'm going to do. I'm going to do that in stages though. So 5 times by 4.1, well, 5 times by 10, 4.2 times by 10 would be 42. So times by 5, it's going to be half of that, so it would be 21. So I'm looking at 21 minus 7 divided by 4. 21 minus 7 is going to be 14. So I'm looking at 14 over 4, which is going to be 7 over 2, which would be 3.5. 3.5, so 3.5 centimeters. Now I made a mistake. The stick was not 7 centimeters long, it was 17 centimeters long. How does this affect your answer to part A? Well, if we think about tracking back, we would have taken away a bigger number here. So in effect, this number would have become 4 divided by 4, so it would have been 1. So my answer would be much smaller. So, so in effect, I'm going to kind of track through what changes it would have made. So it would have been minus 17 instead. So minus 17 instead. So this would have in fact been 4 over 4. So this would have been 1. So how would this affect your answer to part A? My answer would be much smaller. 1, not 3.5. Don't think I really need any more detail than that. That would be how I would go about that question. Okay, question 19. Simplify, giving your answer as a power of 2. So I'm going to simplify the bracket first of all. So when you multiply, you add the powers. So that's going to become 2 to the power 3 to the power 6, to the power 2, sorry, which is going to give you 2 to the power 6. 2 to the power 6. Okay, question 20, bringing in a bit of ratios. Rosie, Matilda and Ibrahim collect stickers. Number is 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. Work out how many more. Right, so I'm going to put those ratios again just in a format that I can use them a bit more comfortably. 4 to 7 to 15. And then the information, Ibrahim has 24 more stickers than Matilda. Ibrahim and Matilda, so he's got 8 more parts. So 24 divided by those extra parts is going to be equal to each part being worth 8, 16, 24, 3. The question says, Ibrahim has more than Rosie. How many more? Well, he's got 11 more parts. So it's going to be 11 times by 3, which would be 33. Okay, question 21. It would take 120 minutes to fill a swimming pool with 5 taps. How many minutes would it take to fill a pool if only 3 taps were used? This is an example of inverse proportion, but a fairly straightforward one. So in effect, 120 times by 5 has to be equal to x times by 3. Because they multiply to make the same value. So in effect, 120 times by 5 is going to give me 600 is equal to 3x. Divide both sides by 3. 200 is equal to x, so it will take 200 minutes. I don't need the m. State one assumption that you've made in your part A, and the assumption I've made is that all taps fill at a constant rate. So all taps fill at a constant rate. And that's a real common 1-mark question that they add on to the end of a direct proportion question. It can be, hi sir. So all taps fill at a constant rate. And that's a real common one marker at the end of a direct or indirect proportion question. It could be men and building a wall, men and painting a fence, or well, people and painting a fence. That's a bit sexist of me. Anything like that. It's that they work at a constant rate. So taps work at a constant rate, people garden at a constant rate, that kind of thing. Right. Okay, question 22. Rowan writes down these numbers. A to B is 1 to 3, B to C is 6 to 5. Find A to B to C. Combining ratios, real standard method for this. I will write them over each other. B to C, 6 to 5. If you're combining ratios, you will have one part that has a value in each part. In this case, it's B. Lowest common multiple of 3 and 6 is 6. To get both ratios with 6 for B, I'd need to double the first one. So that would be 2 to 6, and the second one doesn't need to change. So 2 to 6 to 5. For part B, express A as a fraction of the total number of all three numbers, A to B to C. So that's going to be 2 out of the number of parts. So we've got 2 out of the number of parts. The number of parts is 5 plus 6 plus 3. That's 13. So 2 out of 13. And then the final part, Emma writes down 3 numbers, M, N, and P. Find the ratio of M to P. So I'm going to do this using ratios again. So I'm going to go N to M to P and then put in the bits of information that I've got. So if we're using a ratio of 1N is equal to 2M, it means that I can put the ratio 2 lots of M is equal to N. So we've got 2 to 1. N is twice as big as M. And likewise for the other one, but I can say that 5 lots of N is equal to 1 lot of P in terms of ratios. Yeah, so my quantity to combine here then is going to be N, so that would be 10. I need to times the first one by 5, so that would be 5, and I need to times the second one by 2, so that would be 2, and I feel like I've made a mistake here. Let me just double check my working. Yeah, I've done this completely wrong, so I need to rewind on that. So 1N is equal to 2M and 1P is equal to 5N. So I got my ratios wrong to start with. So my combination is 5 times this one by 5, so that would be 10. I've times this one by 2, so that would be, no, that would be 1. But it asks us the ratio of M to P, so that's M to P 10 to 1. Apologies for that miscalculation right at the start. And I've written it the wrong way round. Okay, question 23. Use these graphs to solve the simultaneous equation. 2 equations cross at an intersection point. The point where they intersect is going to be our solution. So they meet at the point 6 minus 2. So that's x is 6, y is minus 2. Okay, question 24. Use a ruler and a compass to construct a perpendicular bisector of this line. Okay, so for this, realistically, we need a compass. I can't really emulate a compass particularly well. So what I'm going to do is kind of explain it using a protractor. So I want to open my, you can imagine this is the point of the protractor, this is the point of the pencil, and obviously it will create an arc when when you use a pencil on it. So I'm going to open my compass arms to somewhere where the compass, the pencil will hit the line twice. I'm then going to arc in 2 points on the line. So I can either do 2 points or I can just do one arc. Doesn't really matter. What I'm going to do then is place the protractor on both of these points. I can close my arms if I want to, but I'm just going to keep it constant. And I'm going to arc on below the line from one side. Keeping my arms the same, I'm going to do the same from the other side. So I was arcing then, I'm moving. And the point where these arc, P and this double arc here, will create a 90-degree angle with the line. So now I switch for a ruler. So spin it round and ignore the number on here because it kind of cheats it. But it's going to be a straight line through the arc and through the point. So you can see that I've drawn that pretty accurately by the fact that it's a 90-degree angle. But there we go. Ooh. And again, I want to draw rather than move. There we go. So that's my perpendicular bisector showing all my construction lines. So this is my first set of construction lines. Could have been 2 separate arcs. Did it as one continuous arc. And then I placed my point on each of the arc lines and arced below the line. Where the 2 arc lines crossed, that became my perpendicular bisector. Okay, question 25, work out the value of V. So we've got some basic substitution, but fairly complicated in terms of what we actually need to do with it. So it's U squared, so 12 squared, plus 2AS, so that's 2 times by 18 times by minus 3. So that's going to be 144 plus, and I'm going to do this, plus 2 times by minus, 18 times by 3. 8 times 3 is 24. So we're looking at 54. So 2 times 54 is 108. So this is 144 minus 108. Which gives us 36. So V squared is equal to 36. So V is going to be equal to plus or minus 6. So plus or minus 6, technically speaking. But if you just got 6, that would be absolutely fine, I think. Just having a quick look for 6 or for minus 6, except plus or minus 6. Right. Okay, question. Oh, sorry, the final part to that question. Make S the subject. Okay, so I want a minus U squared from both sides. So V squared minus U squared is equal to 2AS. Divide both sides by 2a, so S is going to be equal to V squared minus U squared divided by 2a. Right, question 26. Diagram shows the prism placed on a horizontal floor. The prism has a height of 3 meters. The volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 Newton meters squared. Work out the force exerted by the prism on the floor. Okay, so the prism has got a height of 3, so the area of the prism is going to be equal to 18 divided by 3. So the area of the prism, sorry, the area of the bottom face, I was just trying to work out 1, 2, 3, 4, 5, 6 of the hexagon would be 6 meters squared. So if we're told that pressure is equal to force divided by area, then that means that area is going to be equal to force divided by, sorry, I'm writing the wrong one down. The force is what we're trying to work out. Force is going to be equal to pressure times by area. So we're looking at 75 times by 6, which is going to be 400. So 450. Okay, diagram says a prism. The cross-section of the prism is a right-angled triangle. The base of the right-angled triangle is 7 centimeters. The prism has a length of 25 centimeters. The prism has a volume of 75 centimeters cubed. Work out the height of the prism. Okay, so I'm going to work out the cross-section first of all. So I'm going to say that we know that the volume is equal to the area of the cross-section times by the height, or times by the length. So 750 is going to be equal to the area cross-section times by 25. So divide both sides by 25, that would give me 30 is equal to the area of the cross-section. Right, the area of the cross-section is the triangle, so it's a half base times height. And we know some of these dimensions, so 30 is equal to a half of 5 times by the height. So I'm going to do this in 2 stages. I'm going to double it, so 60 is equal to 5h. Divide both sides by 5, 12 is equal to h. So the height of that would be 12. Okay, final question of the paper, question 28. Just double checking, yeah, final question. So it shows the square ABCD is 10 centimeters squared. Show that. Right, so the area of each section. This area would be 9 centimeters squared. This area would, I don't really need the units for now. The area of this would be 3x. The area of this would be 3x. And the area of this would be x squared. And we're told that the total area is 10. So x squared plus 6x, that's 3x plus 3x, plus 9 is going to be equal to 10. So if I minus 9 from both sides, x squared plus 6x would be equal to 1, which is what we were asked to show. Okay, and that brings us to the end of the paper. Just a reminder again, this is a predicted paper based on common questions. I do think that was quite a challenging paper. So a lot of the predicted papers have been a little bit easier, on the easier side. I think that I've missed out a lot of the easier questions and included a lot more common, more difficult questions. So I do think that your actual exams should be, hopefully, easier than that, but there should be a number of those topics covered within it. I hope you found it useful. Any comments, questions or feedback, please add it to the chat for the video. And other than that, good luck for tomorrow. Hope you do exceptionally well and get everything that you've worked exceptionally hard for.